Hey guys, this is Sikramel.io and I'm back with another Golang tutorial today. And today we're going to be talking about structuring projects in Go. So I write a lot of Golang projects and I stick to the same kind of structure for all of them because it helps me and use the utilities as well as I can. And also I think some pretty good standards for how to structure your Go projects. So today we're going to be looking at an example of structuring a Go project. And if you like the Golang tutorials that we're doing, please remember to like the video and subscribe to the channel. So let's get going. So here we are on our trusty editor, and the program that I prepared for this tutorial today is a bogus program called Weatherman. And basically, as it says here, it's a useless program. What it does is you ask it for some weather information, you pass it some coordinates, and it will give you a string back describing the weather where you are. And really, the purpose of this tutorial is to go through the structure and the tooling of the project more than what it actually does. And so it's just emulating API calls under the hood. We'll take a look at that. But essentially, it doesn't do anything particularly cool. But what's hopefully cool is the way we structure the project and the tooling that we get out of it. For example, some of the tools we get when we follow this kind of structure is we have a Makefile, which we'll walk through in a second. And make is once you make targets, for example, we can generate mocks, which will generate mocks of all our interfaces in the Golang project. Once we have those, we can run our unit tests. Literally run some unit tests, and we'll walk through all this in detail in a second. We can also see just how much cover our unit tests give us. So now we run the unit tests, and it actually brings up a web browser, a HTML page. We can see the kind of coverage that our tests have in our code, and we can see where our tests are falling short of testing the things we need to be testing. And of course, we can build our project and run our project. So let's go ahead and run Weatherman just to show what it does. And so I ran it here, and it said starting Weatherman, called it with some coordinates, and it says asking the Oracle for a response, and we got a response from the Oracle, and the response is rain and wind are in your immediate future, my friend. So I'm in Northern Europe, and so this is probably very accurate weather forecast for Northern Europe. It says today will likely rain, and tomorrow it will probably rain too. Also, had you heard of this thing called spring? Not for you. Winter is coming. Eternal winter. Strength, friend. So again, this is a very accurate, even if it's kind of bogus, weather and forecast for Northern Europe. So let's get started looking at the structure and the tooling that allows us to bring all this stuff together. So as you can see on the left here, we have a bunch of folders in this project already. And before we go through them one by one, I want to give a shout out to a resource on the internet, which is the Golang standards project layout repository. I'll put a link to this in the description below, but essentially it actually provides a lot of the motivation for why I structure the projects the way that I do. And it also means that it's somewhat, even though it's not an official standard, it's one that a lot of people follow. And so if you come across other repositories that look similar, you'll be able to understand why they structured. And in the way to do so, I'll put a link to this in the description. And a lot of the descriptions and motivations for why the folders are the way they are covered in that. So Brandon and I, let's take a look at, so the bin folder up here is what was just created when we built our program, so don't worry about that. That's just where the binaries go from the compilation. The first source code folder is the command folder. So what I typically do is in the command folder, I like to have a subdirectory for every executable that the project builds. So in this case, Weatherman is command one application. And so it just builds one command line target or one executable called Weatherman. And so it has a main.go. And one thing to note about the source code in the command directory is I tend to keep these files really small. They're meant to be really thin shells that just invoke or instantiate and invoke logic from other parts of the project. So in this case, I put the main function here, right, for Weatherman. And all it does is just instantiate some of my internal packages, and then it calls an endpoint or an entry point into the external internal packages, and then prints the results. So this is the kind of shell that you want in a small thin shell. And for that reason, I also tend to not write unit tests for things out here in the command shell. I tend to just keep them really simple and have them invoke other things that are tested elsewhere. And so the next one is a lot more interesting, which is the internal folder. The internal folder is where all the internal packages of your project should go. And this is really where the bread and butter of your business logic goes. This is anything that is internal to your projects. You don't want to share it with anyone else, but it really makes, it's the actual business logic for your application. And so for Weatherman, we put two projects or two packages here. Logger is the first package. Logger is very simple. Basically, it's just as an example, it's a implementation of a logger. All it does is it keeps track of all the messages that you've logged until you flush it. And it also, if you pass it a boolean, you can also print to console. So basically, using FMT, the printf, you can print debug and error messages. So this is a very simple logger. And then for the logger, I've written some tests as well. So I like to use behavioral-driven testing. So basically, write what the thing is supposed to do, administer it if it does that. Let me know in the comments below if you'd like me to do a longer video on how I write tests, both unit test, integration tests for Golang projects. But I tend to use libraries called Ginkgo and Gomega. And in this case, I've just written some very simple unit tests that, check that it stores debug log messages and stores error messages. And these tests live right next to the actual source code implementation. So logger goes there, and the logger _test.go is just beneath it, so you can always easily find the unit tests. And the same is true for the HTTP client. The HTTP client is a very simple internal package that emulates basically calling a HTTP API call to get some weather data. And it also has unit tests down there, which are in the intro. So these packages are internal packages that make up the business logic of Weatherman, and they're not really meant to be exported or used by anyone else. They are truly internal. One thing I could say is that some people like to have another layer in here. They like to have internal package and internal app. That's really up to you. I tend to not do that. I tend to just have my internal packages laid out down here. But this is really where by far the majority of my source code goes in my Golang projects. So the next directory is the mocks directory. This is a generated directory, so don't worry too much about this, but I'll show you what it's for. Basically, we can generate mocks of our interfaces that we use and use them in our tests. I'll share that in a second, but just know that this is a generated directory, so don't have to worry about it. The next one, though, is the package directory. And this is a directory where I put any package in my project that I want to export, basically make available for other people. So I figured for Weatherman is a command-line application. You can run it from the command line, that's fine. But actually, maybe other people want to pull in Weatherman as a dependency of their Golang project and use the client to actually build something cool with Weatherman. I don't think it would really happen. I don't see it happening, but this is an example tutorial. So what we have is, we have a client. This is a package client that's a public package because it lives inside the package folder. And as you can see, the client uses the consumer interface pattern. So if you haven't watched my video on consumer interface patterns in Golang, I'll put a card link to it here and you can go check it out. But essentially, it allows you to inject some things into the client, and then the client becomes available for anyone to use. So anyone can spin up a Weatherman client and ask it for really bad weather forecast if they wanted to. And so just like in the internal packages, the unit tests for client go directly into the client library. And as I mentioned, we have a mocks directory where the mocks for the things that we're injecting into the client actually live. And so using those mocks, we can write really good unit tests that assert that the client behaves in certain ways in certain situations. And so that's what we've done here at the example here of writing a unit test that uses Ginkgo and Gomega and the mock to actually mock what happens when data is returned from the HTTP client. And so anything that's external, basically things you want to export, packages you want to export, make available to someone else, you put inside the package folder. And the final directory here is the integration. The test directory and then integration tests. So what I tend to do here is I tend to put integration tests that truly are sort of either post-deployment or post-compiled integration tests, or just testing things that are truly external. For example, give an HTTP client and that could be calling a server, for example. This is where I would write a test that does that. So I'd mock the HTTP client in here so that I know I can test the different behavioral situations for it. But if I actually want to test it against the real thing, or maybe a development server, I would write integration tests here, and I would also use a similar approach. Again, let me know in the comments below if you'd like to see some examples of how I write integration tests and unit tests for Golang projects. So really the way I use all this stuff, we saw at the beginning of the video how I was actually able to invoke lots of tooling around this kind of structure. And the Makefile is really what ties all this together. So the Makefile, I think, is an important thing. You don't strictly need a Makefile when you're working with Golang. You could just, call these function or call these terminal commands yourself. But I like to have a Makefile because it allows me to be consistent and allows me to have targets that do civil things, and it's just a really handy thing to have. So I demoed these different targets at the start of the video, but essentially, if you use the structure and you use this kind of Makefile, you get these things for free. And so typically my Makefiles in projects, they grow a lot bigger than this because there'll be project-specific stuff. But these 5 targets are pretty much always in my Makefiles. They really are the bread and butter. They're building like executable, they're running it. They're running a unit test, integration test. They're running them with cover so you can make sure that you haven't, missed out on anything. And they're generating all the mocks that you need. So I had it here. Mockery is a tool that's required for generate mocks. So you can usually get mockery from your package manager. So if you're on Mac OS, you can install it with Homebrew. If you're on Linux, because like me, I use Arch, by the way, you can install it from Pacman or from BUR. It's up to you. But essentially, it's a tool that generates these mocks that we can use in our tests. And so I'd like to have a make target for that so that I can just generate the mocks and make big changes that need to be reflected in the mocks. And so again, once we have this make file, we can invoke all the make targets that we want. We could do a lot of automation. The Makefiles are really very versatile and allow you to make your project do exactly what you want it to do. So that pretty much sums up the structure video that I wanted to give you. It's basically just an example of how I like to structure Golang projects, and let me know in the comments if you have any questions, anything you want me to go into more detail in. I'll also put a link in the description to the source code for the amazing application Weatherman, so you can take a look at it yourself. And if you wanna use the Makefile, again, this is a standard template Makefile that I use for pretty much all the starts of my projects. I think it really allows you to get up and running quickly, and so you can run Weatherman and it will tell you that the weather is terrible in Europe, which is pretty much always true. So thanks for watching, guys.